Hi, everyone. I'm Sandy Chika from Riverside Brookfield High School, just outside Chicago, Illinois. And I'm here today to talk to you about extracting information from data. In this video, we're going to examine some of the potential issues that come with analyzing data. So, what will we learn? Well, I want you to be able to identify the challenges associated with processing data. In order to do that, we need to know the ability to process data depends on the capabilities of the users and their tools. Data sets pose challenges regardless of size, like the need to clean data, incomplete data, invalid data, maybe combining data. And depending on how the data was collected, well, we might not have it in uniform shape. We may need to clean the data to make the data uniform without changing their meaning. And the problems of bias are often created by the type or source of data being collected. Unfortunately, just getting more data does not fix this. The size of a data set does affect the amount of information we can extract from it. But large data sets may pose a problem and need parallel systems, and we have to worry about scalability so that when we work with data sets, the data sets can be processed and stored appropriately. So let's start with an example. Where do we start with data? Well, obviously we have to collect it. So some issues to consider. What's the source? What is the source of the data? Where did it come from? Do you need more sources? What tools do you have to analyze the data? Just a spreadsheet? A calculator? Do you have a whole programming language under your belt that you can use? The processing data is affected by size. So, how much information can you get? And depending on what that answer is, you need to determine can one computer handle all your tasks? There may need to be parallel processing involved. And what I mean by that is using two or more processors to handle different parts of the task.
Whoever is working with the data needs to make sure that the scalability of their system is such that they can adjust for small as well as very large data sets, depending on what their needs are. The other thing we need to consider is bias. When we are collecting data, there could be intentional bias. Who collected the data? Do they have an agenda? We also need to be aware that bias can creep in
Even if we're trying to do a really good job. So there is unintentional bias. How is the data collected? Maybe you did not realize that all of the people or places you went to all have something in common, which is going to lead them to lean a certain direction or lean a certain way. Again, who collected the data could be an issue. So, unintentionally, as a teacher, I might ask my students for their opinion about a lesson that I gave. If I'm asking them face to face, students might feel like they need to make me happy and just tell me only good things. So, there could have been a bias, even though I really wanted them to be honest. So, we need to think about how we're gathering the data. Now, hold on a second. I need to get a little something here. So, yeah, I need to clean my data. Okay, so maybe I don't need to use a Kleenex and clean it up. But I do need to identify incomplete, corrupt, duplicate, or inaccurate records. I may need to replace, modify, or delete the dirty data, but I do need to be careful. If I'm going to modify or delete anything, I need to make sure there was really a reason. Is there really a mistake? Am I actually fixing something or actually making something more incorrect?
whatever I change, modify, delete. I really need to keep a record of that and why I did it. Invalid data may need to be modified to keep the form consistent, but I want to be careful. So let's look at an example here. Let's practice. I have some sample data with student IDs, their years in school, and their GPAs. What data needs to be cleaned in this example? Pause your video for a moment and see if you can find some data that needs to be cleaned. Okay, I hope you came back and actually looked at it. So here's some things that I found. I could see that there was a missing data point here. I have a student ID that's missing. There's also some invalid data here. Although junior is a legitimate way to say your year in school, I can see that the majority of data is listed as 9, 10, 11, or 12. So I might want to update that so it's more consistent. Same thing with ninth grade. I can see that's a freshman. I can see it's a 9, but now that's not in the form of an integer. So I might need to update that. Inaccurate data? Well, I don't know of a grade 20 if I'm looking at high school students. That could be a problem. A 4.75 GPA, is that a problem? Maybe. I need to check to see what my situation is. In some schools, 4.0 is the highest GPA you might be able to have, but I better verify that before I make any changes. So, what data needs to be cleaned? I've cleaned up the data and I highlighted it in red. Some decisions were made pretty easily, others had to take some research. So, for instance, I had to research to find that student ID number. These were pretty easy, but I did need to double check that that 20 was really a 12. I wasn't really sure what had happened there. And it turned out when I did my research that students can get higher weighting for certain classes, like AP classes at the school I was doing my research. So a 4.75 was a correct GPA. So that's why you don't want to jump to conclusions when you clean your data. Now, when you look at data from outside sources, you might need to ask questions about what type of data cleaning was done and how decisions were made to make sure they did not introduce either intentionally or unintentionally any bias. So, what should you take away here? Well, hopefully, you can identify challenges associated with processing data. The ability to process data depends on the capabilities of the user and their tools. Even if we have no problem with size, we might need to clean the data, fixing incomplete, invalid data, or combining data sources. If it was collected in a different way, we might have to make sure that the data is uniform. And cleaning allows us to update the data without changing their meaning. Bias can creep in, and just eliminating the bias cannot happen by only collecting more data. The size of data affects the amount of information we can extract, but large data sets are difficult to process and we require parallel systems. So we need to be aware of the scalability of our systems so we can actually process and store data appropriately. Thank you for watching this video. I hope you'll come back and watch more of the CS Principles videos. In the meantime, go out and have some fun with CS.